Hey there, and welcome. In this series, we are going to tackle the fundamentals of computing. Maybe you've wondered how we talk to computers, or how they work at a basic level, or you're just starting out on your journey to learn programming. Then this mini-series is for you. This mini-series will comprise of 3 videos, each tackling a small portion of the basics of computing, giving a solid foundation to begin learning programming. So, if you're ready, let's begin to dig into the world of binary. For this series, I recommend grabbing a pencil and paper for notes and diagrams, or if you use any note-taking software, to use that. Binary. You've probably heard of it. It consists of 2 digits, 0 and 1. But how does a computer use this? Well, for now, let's not think of them as numbers, but instead as light switches. 0, the light is off, and 1, the light is on. But how is that helpful? How can you count with that, I hear you cry? Well, let me show you. Using binary, we can count to massive numbers, infinitely high. But for now, let's focus on counting up to 10. If you notice at the top of the table, we have the numbers 1, 2, 4, 8, 16, 32, 64, and 128. Let's see how it works. So, with all zeros in the table, we have, you guessed it, 0. Huzzah! Now, in the rightmost column, let's flip that 0 to a 1. Now, we have a 1. Now, how to get 2? Well, let's turn off the 1's column and turn on the 2's column. And now, there it is, 2. Now for 3. We can just turn back on the 1's column and bingo, 3. So what have we learned? We've learned binary has place values, our columns, that double in value from right to left. Each place with a 1 in it is being added to every other place with a 1 to get our total number. Let's do the remaining 7 to show this. Now, let's show you the potential of binary. You've probably heard of 8-bit graphics, 64-bit operating systems. Well, that's binary. Each of our columns or places are a bit. This is denoted with a small b. So, to find out how high we can count for any given bit range, we can just pretend each bit is a 1 and get the full value. So, for 8 bits, we can count to 255. 16 bits, we can count to 65,535. A lot more for just double the amount of bits. And for 64 bits, which is 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709,551,615. Nailed it. Now we know how to count with binary, but how does a computer use this? Well, let's have a look. You've probably heard of megabits, gigabytes, or terabytes. Well, that's all binary. It's a representation of data. All data, whether stored or sent, is in binary. There's complex reasons for this, especially for data transfers being high and low signal states, but that's not for here. So how is a bit a byte? How does it all work? Let's break it down. So, as we know, binary is counted in bits, denoted by the lowercase b. Well, for every 8 bits, we get a byte. This is denoted through the uppercase b. So now we know about bytes. How do we get megabytes, or megabits? Well, you times by 1000. Think of it as a metric system for data, just like how we have 1,000 grams to a kilogram and 1,000 meters to a kilometer. Using this terminology helps us say extremely large numbers with ease. But that's not all binary can be used for in computing. Sometimes it's used to encode, a way of storing values as binary to be decoded into something else, like letters. Here we have the ASCII table. ASCII stands for American Standard Code for Information Interchange. Using the table, we can pick out letters and symbols to make up words, which we can represent in binary. Pause the video and try for yourself. And finally, we have colours. These can be represented in binary. This would be a representation of 8-bit grayscale. To add more colours to the image, we can move up to 24-bit graphics, what we use today. But how? For this, we use 24 bits to denote our colour. Let's break it down. For every colour, we either need an amount of red, green, or blue. Each one of these channels is 8 bits in length, like so. This would give us black, as we have no values. For white, we would use... Now smoosh them together, and we have a 24-bit value. This can give us any colour we want, like so. So, as you can see, binary is a very versatile counting system, used for numerous processes within computing. But it's not the only counting system we use in computing. The next one, commonly used, is hexadecimal, or hex for short. As you can see, it counts up to 16 using the following: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and finally F. But why use another counting system? Well, as amazing as binary is, it's too long to read a whole string of zeros and ones. And base 10 is great, but maybe I just want to have double digits as an output. I mean, I can go all the way to 255 with just FF. It's just a functionally easier way to output large values with minimal digits. And the best way to see this is in color codes. Remember our 24-bit numbers? Now translate that to hex, and we get this. A lot easier to read now, huh? But give it all a go and see how many colours or words you can make or decode. Leave a like and a comment if this helped you, and remember to subscribe too. If you have any questions about binary, hex, or anything related, or just want to share what you've tried, feel free to reach out to me directly at fluffies.bytes@gmail.com. I'd love to hear from you. And don't forget to join me for the next episode in this basic series where we look at logic gates. Remember to have fun and give this all a go yourself.